Mauritius, and today I'll be presenting you the third chapter, which is practical planning. So this module consists of 4 chapters, which is viability study, the link budget, miscellaneous cost, and then implementation plan. So the first one is the viability test, which is also known as the feasibility test. That is, it means if it can be done or not. We can surely get obstacles, but we should assess on different solutions with respect to cost before implementation. The viability study, it is based on 4 pillars. The first one is the availability of the physical infrastructure. The second one is the technical infrastructure that is currently being used. The third one is the closest power source to be able to power our equipment. And finally, we need a backbone to be able to provide a connection for the users. So for the existing infrastructure, the exact location is required. This can be used by using a GPS and updated maps. And we need to assess also the area that is needed to be covered. The existing technical infrastructure should be done, like a survey should be done and so on, because to know if we will have interference and so on. This will be carried out by surveys, and also collocation is feasible. That is, we can collocate on another tower, and also we can split the bills on electricity and so on. The third one is the electric power, the access to electric and power. This should be done because we need to power our equipment, and also a reliable power source is needed with appropriate voltage and ampere. And additionally, a UPS is preferred as for the service for not to get interrupted. And finally, a backbone is required. This can be done by using a wireless system or a wired system. And this will be underground or overground. Fiber cable is, we need to use fiber cable because due to its low loss. And this will be put underground by using PVC pipes so that rat cannot eat it. So now we'll be moving to the next topic, which is link budget. Establishing a good link budget will enable a reliable wireless connection and service to the users. A link budget is the sum of all losses and gains across a full link. This includes the losses through cables, connectors, and free space. The formula, as you can see here, is the received power in dBm, which is equal to the transmitted power in dBm plus the gain minus all the losses. So as you can see here, we have on the transmitter side, we have the cable, the antenna, and then in between those two antennas, you have this free space loss. And then at the receiver side, you have the cable, which is connected to the antenna to the receiver. Therefore, the link budget is the transmitted power minus the cable loss plus the gain of the antenna minus the free space loss plus the antenna gain on the receiver side minus the cable loss on the receiver side, and then we need to minus the whole thing with the receiver sensitivity. And you should know that the receiver sensitivity will be of a negative value. That is, it can be minus 50, minus 82, or anything else. So lastly, we need to account the signal to noise ratio across the transmission path. So typically for a rural area, no over 2.4 gigahertz band is used and no industrial noise is present. The noise level is around minus 100 dBm. Vice versa, in urban areas, it is common to see a high level of noise, which can be which will be around minus 92 dBm. So here the formula of signal to noise ratio is shown. And the typical requirement for an 11 megabit per second speed, the SNR is of 16 dB, and for 1 Mbps, it is 4 dB. So now, the third topic is miscellaneous costs. Aside from radio and network equipment, some items should be considered. So the first one is electricity. So in many developing countries, electricity is not stable. Thus, batteries, battery charger, adaptive voltage regulator, inverters, and UPS. Yeah, it's UPS actually, should be used. The second one is electrical grounding and lightning protection. So regardless installation, all equipment should be protected against lightning. For direct hits, franking rods should be used, and this will be placed on the rooftops or on the top of the towers. Secondly, for indirect heat, which is also known as induction current, a surge protector will be used. And also other miscellaneous costs or tools, transport, license to be able to operate at a certain frequency, and also procurement form part of the miscellaneous cost also. So now we'll move to the last topic, which is implementation plan. So here, there are few practical issues that will help to implement the wireless link. Firstly, weather. So we all know that it is hot and very hot also at the equator and cold at the poles. So proper equipment with correct specification should be installed to withstand such temperature and weather. Second one is quality assurance. Testing should be done so as to match the SLA. Parameters that should be observed during testing is jitter, uptime, throughput, packet loss, and so on. And this has to be done on different conditions, such as weather, like different temperature, also different humidity, even if it's raining and not. Also, it should be done on the different load condition. That is, if less people are using or more people are using, and then we need to get the throughput and so on. So here you can see. Actually, I was working on one project. Like we had to put a Wi-Fi connection to one event. So here it's like you can use the application called GNet Wi-Fi. Once you set up a Wi-Fi connection, and then you can connect to it, and then you can map the received power, and you can see down. You can see the legend, and this is like really useful to be able to know where you're getting Wi-Fi and not. So finally, tilting the antenna is an important procedure of optimization. This will help to maximize the power at the receiver side. In the first picture on the left side, it is a case of point-to-point link. Therefore, the maximum power will be received at its main lobe. And for the second picture, it is more likely to be a Wi-Fi antenna that needs to cover a certain area. So I'll show you the formula for the second picture. So it's actually here. Actually, you can see the antenna here. When it's tilting down, you have the lobe. But with respect to the ground, it's becoming like this. So it's covering this area. So to be able to get this distance, we use those three formula. So first, getting the down tilt angle, we use the first formula, and then the outer cell radius, which is here from here, we will be using this formula. And then to get the inner cell radius, that is from the antenna to the point where the Wi-Fi is starting, we will be using this this one. Therefore, to get this area, we just need to make the outer cell radius minus the inner cell radius, and then we get on this one. And then we can play with the tilt to optimize the coverage and so on, depending on the requirement. If you want, I can show you this link, and then you can take a look at it. So I guess this is all it for tonight.
Wow, that's excellent. Thank you for for the presentation. The recap was very smooth, and
Yeah.
I like that. It was very,
All
very.
right. Thanks.
It shows that you've you've been working in this domain, and also you did a lot of research. Also, thank
Yeah.
you for the link. Please, you need to share that link. Also, you can put it as reference material in your slide. Then you will share the slides with us.
Yeah. Sure.
Send me the slide, then I will share with the rest of the class. And also here, yeah, good. Thank you. So, do you people have any questions for Jirash? Please, any question? Okay, so far, no question. The presentation was clear and straightforward. And this is a very, very important topic, a very, very important module, because there is a say that failing to plan is planning to fail. So if you want to, whatever project you are doing in life, you need to always like do proper planning. And when you have a proper planning, you can have like steps ahead. You can envisage what things can go wrong, and learn maybe from previous implementations. So that's why this topic is very, very important, so that when you are implementing your network, you at least know what are the various things that need to be taken in consideration. So I like that, and we will now pass the floor to Natalie. And Natalie is going to be talking about networking. Yeah, introduction to networking. Yeah.
Yusuf, just make me a co-host, please.
That's exactly how to do.
All right. In the meantime, good afternoon, everyone. I'm Natalie Rose. I'm going to be sharing my screen so you can see.
Okay. So
I'm going to be. Yes, I've seen it. Thank you. So I know several of you guys have been doing our work in the networking field. Some of you guys may be network administrator. Some may not, but I'm going to just break it down, and if you have any question at the end, then you may feel free to ask. All right, so we're going to be looking at the ISO OSI and how we differentiate with the TCPIP. We're going to be looking at the medium access control layer, where we have the Ethernet, the wireless, and we're going to be looking at how we do the encryption for the IEEE 802.11. So in a computer network, you always have two or more machines that is able to share graphic, videos, data. It can be by a LAN, it could be wireless, but how it actually works. And it works by using the OSI model. Now the ISO, which is the standard, was used to standardize the entire model itself. It has these rules that these layers should work with. So we have the different layers for OSI model, 7 layers, and we're going to be looking at those 7 layers. But we have to realize that if a machine is a Mac and another machine is a Windows, how they really talk to each other. And that's where the ISO plays. That's the standard, the rules that the ISO govern the OSI model, so that each layer are able to talk to each other, no matter what type of operating system you have. So ISO is International Standard Organization, and the OSI is a Open System Interconnect. So the ISO is just an organization, but the OSI is the model. Now let's look at the different layers. There are 7 layers, and we're going to be talking about these 7 layers, or discussing these 7 layers. So the first layer I'm going to be looking at is the application layer. Now, I have this blank screen because I'm going to be scribbling some stuff on there so that you can get a basic understanding. Now, what the application layer does, it works with the network. It works with the network application. And when I talk about network application, I'm talking about, like, for example, your browser, Skype, Outlook, and file transfer. So each one of these layers contains its own prototype. And with the file transfer, we're talking about the FTP. For like web surfing, we're going to be looking at, we're talking about the HTTP or the HTTPS. And for email, we're talking about POP or STMP, okay? And we have virtual network, which we talk about Telnet. And I think some of you guys know what Telnet is all about. And that's what happened in the application layer. Now the information in the application layer goes right down to the presentation layer. And in the presentation layer, we talk about how we just have characters and numbers and how these are translated. And when they're translated, they're put they're put into binary or hexadecimal, but the ASCII can be translated into EBCD. Okay, and we have data compression because you want to make sure that your information is small for it to be transported or transferred. So if we have binary 0011, it may be 0101. And then we have the encryption. And the encryption, we are using the secure socket layer. Now this information, all of these are done in the presentation where everything is translated, then the information is then compressed, and finally it is encrypted. The information now moves down to a session layer. It's like planning a party where you get the guests, when the guests, you make sure everybody is seated, food is arranged, then after the party, you clean up. The session layer is like that. It's set and manage the connection. So it uses something called authentication. And authentication is where it works with the server, where you have to provide a username and password. And then you have authorization. And authorization is, if you're going to access a file, should you get that permission to get access to that file? And the last, it has a check data packet, where it uses something called a checksum. So you have to make sure that everything is fine and there's no errors when you're transferring your data. The next one is a transport layer. And with a transport layer, the data that you get from the session layer is now divided into segments. So we're talking about segmentation in this layer. And once you have the segment, you'll have a sequence number, because everything going to split up into different segments. So you have to compile or join everything back. So you have a sequence number and you have a port number. Now, the port number will direct you to the correct application or the assembly it and put it to the correct correct application where it's supposed to go to. And then the sequence will give you what correct sequence it should go to. Now, the thing about the transport layer is that suppose I have a machine. This is my client machine. And this is my server. And my client machine is my mobile. And I'm trying to access or browse the internet. But my server is going at speed 50 megabytes per second. But my mobile can only take 10 megabytes per second. What will happen here is that this server would realize that this mobile can't take 50 megabytes per second because it would have sent a message to the client or my mobile and realize that this is only running or can actually download and the information at 10 megabytes per second. So what the server will do is to cut down the information transmitted back to 10 megabytes per second so that the server, this mobile, can be able to process that data. In the transport layer, there are also several other prototypes that it uses. For example, it uses something called the TCP and the UDP. So the transmission control protocol and the user diagram protocol. Now, the TCP is connection oriented. And this is much slower because it needs a feedback. And this one is connectionless. And this is much faster and there's no feedback. So when I'm downloading videos or songs or video, it's actually using UDP. However, we're talking about sending email, going on the browser, we're using the TCP. The next layer is the network layer. And with the network layer, that information that is sent, which is those segments, are now broken down into packets. So now we're working with packets in the network layer. And in the network layer, we talk about logical addressing, routing, and path determination. Now, in the logical addressing, we're talking about our IP4 and IP6. And with the routing, it allows you to make sure that you reach your destination. But then with the routing, it uses the mask address to find out if it's going from one network to a different network. And the path determination is going to find the best path using a different algorithm. The fastest path or the best path or the optimal path, that's what it does. Then the next one is the data link. And in the data link layer, we do have logical addressing. And with the logical addressing, that's what the network layer would do. And the physical addressing is done by the data link. Now, with the physical addressing, you have the MAC address that will send out, and you put everything are now put in frames. And what it will do, if you're sending to the receiver, you'll have an entire MAC address for the sender, MAC address for the receiver, the IP addresses for both the segment and the tail. So everything is put into a frame that will have the data packets. And everything, the MAC address do have 12 digits with alphanumeric, like hexadecimal. So it's built factory built from the manufacturer. So every machine will have a MAC address. The role of the data link is that it will do your, it place it and receive it on the media access control, and that is what we're going to get to know. So everything from the upper layer to access the media are put into framing, and how the data is placed and received from the media is now going to put into a media access control, which is called the MAC. And that's what we're going to be explaining. Now, the last one is the physical address. And with the physical address, the bits are converted. So physical address, the bits are converted into signal. And these signals can be a radio signal. So if it's a radio signal, we're talking about it's going to be transmitted by air. If it is light, we know it's going to be optical fiber. And if it is electrical signal, you know it's going to be some form of copper cable or coaxial cable. So this is just showing you that the data leaves the receiver application, go to the segment, go to the it does encapsulate, put it into segment. That segment is turned into packets. That packet is turned into frame, and then it goes into the physical layer where it now turns into zeros, one, and send the signal through the router or routing mechanism and goes back to the receiver, back up to the packets, converting in packet and segment, transportation right up to the application layer. So it decapsulates. All right, so the TCPIP model, there are being four layers for the TCPIP. Those was the original ones. But since this year, it's no longer for CCNA. Cisco now have 5 layers, which is the updated TCPIP, right? So we now have the physical and data link, the network, transport, and application. Now, IP version 6 uses hexadecimal, so it's 48 bits, 12 hexadecimal, and is for it. So because we're running out of IP4, we are now asking companies to move on to IP version 6. So this is the addressing for IP version 6. I think I explained this before. This is an explanation of how the physical address works. If you are the sender and you have a address 10 and you want to send it to address 87, puts it into the frame, it propagates it to everybody on the LAN, and if they are not the right machine or client or port, it will discharge that frame, and making sure that, because it doesn't belong to them, and then it make sure that it is sent to the correct client, and that current client machine will actually receive that frame or packets. So that's the physical address into the data link. Now, the logical address here, we have 3 different networks, and we are sending the information from A to P. As soon as it goes along and go to another network, its IP address will change based on the master address for that network, and it will forward that frame or packet. That packet will change based on the route or network is going through until it reaches the destination. So a physical address will change from hop to hop. But when you're doing the logical address, it won't change. It will actually have the same address. Now moving on to the media access control. Now this protocol, all it does is how you're going to share the information. So both the Ethernet and the Wi-Fi, they do have multi-access technology. So they will share using the media, but then you're going to have collision. How do we resolve collisions? We can use the Aloha, but when the package are sent, multiple people if multiple persons try it, you're going to have collision. And what the Aloha will do is to actually send it at a later time. This is not a really good technology because it uses Poisson distribution. So they develop other technology or techniques called the CSME, which is a carrier sense multi-access. So listen to the line. If it is busy, it won't send anything. It puts a random time. If it is, so it waits. If it is not busy, then it will transmit. But collision will still occur. So you have something called a collision detection. And this is for the Ethernet. This does not work for Wi-Fi. So with the collision detection, it listens to see if there's any package that is sent out. If there is a collision, it will stop sending it, use a random time, and then it will send off the information again. For wireless, we use something called collision avoidance. If you look at this diagram here, it will send the information through the medium. If the medium is not busy and there's no collision, then the data is successful. But if there is a collision, then it's going to do a random delay and send back the information to the receiver. Now, what's the difference between the collision avoidance and collision detection? Now, with the collision avoidance, it prevents the collision before they happen for the wireless, because you can't use collision detection on a Wi-Fi. Now, once you're on a Wi-Fi, you have security issues. And one of the earlier security measures that was the WEP. Now, this uses a 40-bit, but it was very much insecure, so they move on to WAMP. Now, with WAMP, this came out in 2003. It has a stronger encryption, and it actually replaces the WEP. They continue to go on and build the WAP 2, which is approved for the IEEE 802 level I, and this one has more security, and it uses the ASE algorithm. So what this does is that they use, with the web, it uses something called a CRC algorithm that uses like a linear function. And because of that, hackers were able to go in, know what the algorithm would, how the algorithm works, and find loopholes. And from those loopholes, they are able to actually crack the system. And that's my presentation. Thank you so much.
Wow. That is good. Yeah. So Natalie, thank you very much for that very interesting presentation. And just a few clarification. So you talked about STMP, it should be SMTP. Okay, it should be SMTP 1. And talking about, I guess it was just a typo. I'm very thankful to Diraj and Natalie for taking their time and making this presentation and preparing the presentation and delivering it. It was very, very, very straight to the point and very rich. And we'll expect those who will be doing the upcoming weeks to stick at least to the standard. So you people, you set the bar very high and the others have to suffer for that. So I will have to say the best way of learning is by teaching. So if you want to learn more, you have to start teaching. And because for you to teach, you need to try to understand a little bit. And, then when you teach, you now understand some mistakes you are making and you can correct them. So it's very good. And when I joined the networking field a couple years back, I used to think of the application layer as these applications, these standalone applications on our computer, like Word, the Microsoft Suite, and all of those. Then I later realized that the application at the application layer, as Natalie presented, is any application that can participate in networking communication. So like when you go into your browser and you type, let's say, HTTPS or HTTP www.google.com, there is actually like a connection from your device to the server that is open. And because of that solicitation to the server, that's what makes that browser an application at the upper layer of the OSI module. So it's not any application on your device that is, considered an application in the OSI module. So there are a lot of them, as she named the browser, she named the file transfer, she named the HTTP, she named HTTPS, SMTP, DNS, and all of those applications that we know making our communications like available and possible on the internet. And also at the session layer, when we are talking about authentication and authorization, don't look at it as like using a username and a password to authenticate. It is some sort of mechanism behind the scene that's like try to authenticate the sender and the receiver. So if we look at the perspective of, let's say, IPsec, where you use something like authentication header, when a packet is generated at the source, it is there are some instruction or some parameters in the packet that when it gets to the destination device has to like look at those information to make sure that the packet that was originated at source was not interfered with during the transport, and that the person or the device saying, I am claiming to be the one sending the packet, is exactly that device we want to talk with. So that's like some behind the scene mechanism that happens to authenticate various parties in a set of communication. And when we talk about let's say at the transport layer, that, as she said, she mentioned the TCP and the UDP. And there is one thing I want to specify here, that TCP is sort of reliable, while UDP is not reliable. When we say reliable, it's not as if when you are doing UDP, you are not sure that your communications are going to be effective. No, it's just that the applications that are using UDP are applications that can withstand, like, can afford if a packet is lost. Like, let's say I am talking to you right now. If a bit is lost, you can still understand what I'm saying. If you are watching a video of me, like right now, if I put my video here, you can see me. If packets are lost, you can still like identify me. If let's say a bit here is missing, you can still identify me. You don't want for UDP that if a packet is lost, they should retransmit it. If they retransmit, let's say I'm saying something right now and a bit is missing, and then later on that bit is sent, it will distort the communication. So for those types of communication where it is real life, you don't want it to be reliable. You just want the flow to happen. If packets are lost, don't care about it, just keep on moving. And for TCP, as she explained, she said for communications, things like mail, web browsing, if a text is sent, if a bit is missing and that bit is not sent back, the text cannot be reconstituted. So that's what makes the big difference between TCP and UDP. So that's what I had to like add. This topic, introduction to networking, is very huge, so we can't like cover everything in a single presentation. If you have questions, I have seen on the forum, on the course forum, that there are a lot of participants, there are a lot of people who take time to go and ask questions and some time to try to respond. If you have questions, please go there in the forum of the course, ask your questions and we'll attend to you. Now from Jiraj, there is someone who has a question for you. I hope Jiraj is still here. Alejandro said, not sure about the concept of margin. Should it be considered a gain? Yeah, Jiraj, can you try to answer that question? Margin, the margin, is it a gain or what? So the margin is not really a gain. It can be a gain or a loss, right? When we talk about margin, when you are doing, yeah, exactly. So it is the sum of losses plus gain, which will result to a specific value. Let's take the normal budgeting. Say I am budgeting to, like let's focus on finance. I'm budgeting to set up a wireless network. And for that wireless network, I know that I have to buy antenna, I have to buy power supplies, I have to buy receivers, I have to buy access points. Then I have, let's say, a budget for each of those. Let's say I say the access point is $100, and then I say maybe the power supplies, let's say $25. Then when I go to the market, I realize that the power supplies, instead of $25, is $30. That's a margin. I have a margin, a loss of $5. Then I go for the access point. I budgeted $100. Let's say I realize that it is less. Let's say $90. I have a gain of $10. At the end, what I'm going to do is I'm going to sum all of these values, and that will be the global margin for the entire project. And also, that is like in the execution phase. Now, when you are planning, let's say if you are planning to buy a device that is, let's say, $100 per your evaluation, always like think of a margin, add something like say 30%, so that you are not surprised actually when you hit the market. I hope that is a bit clearer for Alejandro. Wasn't aware that TCPIP model was updated. Yeah, it is updated. There is, I think, the version 6 of TCP is out. So yeah, and yeah. Now talking about TCP and UDP. OSI model and TCPIP. Which one do you think is the best? Please type in the chat. Which one do you think is the best? TCP/IP or UDP or OSI? Which one do you think is the best? And if you can tell us why, then good. Please type in the chat. Do you even know the difference? Natalie just presented it very clearly. Okay, so yeah, I am waiting for you guys. Please type in the chat. TCP/IP versus OSI model. Which one is the best? Okay, Alejandro is like, it depends on the type of information you want to send. Okay. Lindell will say it's OSI model. Please, you need to tell us why. Go ahead. We are 13 in this chat room. Please, let's make this lively. I think they each have their individual uses. Okay, TCP, I think. Jiraj, Jiraj, can you tell us why? Like just a short sentence, not need to like have a long development. And yeah, okay, the others will not like to participate. So It is always very important. Yeah, Jiraj is saying OSI is a model. Then TCP IP, we are actually using it everywhere. Okay, my question for you, Jiraj, do you think there are OSI implementations out there? Is it used like in networks? Titus is like, yes. Jiraj, everywhere I mean network. Can you repeat? Yeah, I'm asking, do you think there are actually implementations of the OSI model somewhere like on your computer? Do you have any device that implements the OSI model? Natalie, you need to say something. You are the champion of this chapter. Someone said TCP IP is based on OSI model, therefore they work in tandem, but practically it's TCP IP in use. Okay, that's sort of true and a bit mixed up. All right, let's go back to the history. Yeah, let's go back to history. Actually, the two models were competitors. The OSI and the TCP IP were competitors from the beginning. And if you look very well at the TCP IP and the OSI, you see that the OSI model is more elaborated, more concise, and more easy to understand compared to the TCP IP. TCP IP is stacked just like OSI, but because it has like less number of stacks, it is not like very easy to understand compared to the OSI model. So the OSI model at the beginning was meant to be used like the TCP IP model, but at the end, the TCP IP won the game. And it's not because the TCP IP was the best that he won the game. It's just like some politics around there. You know, in the world of on the internet, we have a lot of politics. So actually, to my understanding, OSI model is the best. And so because it is the best, we now decided, since TCP IP is broadly implemented, to use the OSI model as a reference model. As Natalie explained, Natalie said OSI model is the model of models. So actually, people use the OSI model to standardize their models. Like at any level, if you look, when we are talking about, let's say, mail, we are talking about email. We look at it at a perspective of OSI, not on TCP IP. Though it works at TCP IP, but to better understand it, we look at the perspective of the OSI. So the OSI is like the model of models. And right now, yes, your device actually does OSI. Surprise, right? Your device actually does OSI. It's like major vendors actually implement OSI. And if you decide today that you want to use OSI, go ahead, you use it, and it will just work the same as your TCP IP model is working right now. Just that their addressing is at layer 2. It is called NSAP addresses. And if you know routing protocols like ISIS, you understand that ISIS was created to route in OSI networks. So if right now you want to configure, if you can configure ISIS on your device, it means that your device supports OSI. Okay, so that's what I had to add on that one. It's very important to make that difference. Okay, so Patrick says, I see OSI troubleshooting network and it's a standard. Yep, you use it to understand how networks work, eventually to troubleshoot. Actually, I don't like that word of troubleshooting. I like debugging. Okay, so Lindell, you can write on Telegram. I'm always there. I'll always read all messages that are sent on Telegram in the Telegram group. So please, if you have any queries, please just drop it there. Emails, the turnover of email, it takes some time, so it's better we do instant messaging. Any questions? Okay, I think, yeah. I think this was a very interesting meeting, and let's think about next week meeting. NTSP, is that a protocol? Please let us know your question. What's your question about? NSTP, you have the floor.
Okay. Can I ask on audio?
Yeah, it's okay.
All right. I wanted to find out in regard to what was said that the TCPIP has been updated to 5 layers. Yes. Is it up to Cisco to do it, or it has to be the standardization body that does it?
No, it's not Cisco. It's actually done by the how do you call them? The IETF.
Oh, okay. So it was done universally.
Yeah, it has to be universal. You know, we saw in module 1 that standards are made so that we can talk to each other and understand ourselves. So about the 5 layers, actually, I'm not yet aware, but I know there is a new version, the version 6 of it. So I am just from learning also that it's 5 layers. So I'm going to find out about that, as well as we can also do that. Okay, Natalie, thank you for sharing. So it's not it's not something related to a specific vendor. If we have to change a standard, it has to be universal.
All right, thank you.
All right. So thank you. Natalie shared a link and I'm sharing it in the group. Thank you guys. Thank you for your time and see you next week, same time.